Welcome to multiple linear regression. So with multiple linear regression, what we're able to do is see which of multiple predictors are actually statistically significant. By statistically significant, what we mean is, does that predictor move the needle? In other words, picture the regression line and picture the slope on the regression line. And we're looking for predictors that would actually move the slope away from the horizontal. So if a predictor is statistically significant, then it moves the slope away from horizontal. Okay, so let's look at the first one. Startup. Analysts are interested in understanding which factors most influence a startup's monthly revenue. A data set was collected from 30 startups, including ad spend, social media, reach, active users, customer rating, and subscription price. Conduct the appropriate hypothesis test to determine which variables significantly predict monthly revenue. Use an alpha of 0.05. And so you will need to use the provided data to estimate the regression model. The data is in the next tab. And it will be for all the problems. The data will be in the tab following the problem description. So then you're going to complete the coefficient table in this tab for the final model. And if a variable was not included in the final model, put NA for both the coefficient and p-value. And then complete the prediction table. And then answer all the questions down below. So this will make more sense as we start to do it. So here's our data, and in most cases, we put the y variable in column A and actually put the little letter y above it, just so you'll know it's the y variable. But what that means is that all the other columns are x variables. In other words, these are the predictors, and each one of these presumably helps predict monthly revenue. So we're simply going to see which are real predictors and which really are not. So to do this, we pull up the data analysis toolpack, choose regression, and for our Y range, we pick monthly revenue. And notice that when you, and that's in thousands by the way, so is ad spend, that'll come into play later. Notice that when you highlight it, you include the column heading. And then the X range is going to be all of the X variables. We pick labels because we do have the column headings for labels. And then click confidence level for 95%, which is effectively that is our alpha of 0.05. And then for our output range, we're going to pick this spot right here, or it doesn't have to be exact. And then click OK. And now, while it's still highlighted, this is really important, do not click off of it while it's still highlighted. Come back to the Home tab and pick number. And that should format it to 2 decimal places. If it doesn't, play with these until you get 2 decimal places, because you need 2 decimals to see the p-values. So the way this output is arranged, it's identical type output as simple linear regression. The difference is in this bottom piece here, instead of just having an intercept and one predictor, we have an intercept and multiple predictors. So we're looking over here at the p-value column to see if any of these predictors have a value greater than 0.05. And you can see that 2 do. The intercept at 0.28, and in this case subscription at 0.92. Now, the thing is this, we never care about the p-value for the intercept because it's not like we can get rid of the intercept. But we do care about the p-values for the predictors. So in this case, this means that subscription has to go. So we're going to run the regression again, this time knocking out the subscription price column. So I'll go ahead and delete that column, and then I'll run the regression again. All right, now these ranges should actually be good. Everything should be good here except for two things. The X range is going to have to change, and the output range is going to have to change. So let me show you why. If I click on the X range, you'll see that it includes the column that I deleted. So I have to redraw that, not including the deleted column. And the output range has to change because I want it to appear here. So click on output range, and then click here below the first output. And those are the only two things that I should have to change. Click OK. And again, while it's still highlighted, go to the Home tab and pick number. All right. Now, as we look at the p-values, they're all good. All right, shoot, I shouldn't have clicked off of it because I actually want this now. So I'm going to copy this whole thing. And this now is our final model. Come back to this page, place the final model here. And now we're going to reference the final model over here in our coefficient table. So here we have the coefficients horizontally. Here we're going to have the same thing, but we're just going to have the coefficients vertically. So we're just going to say equals. This is the coefficient for the intercept. And then equals, and then the coefficient for the p-value associated with the intercept. Equals coefficient for ad spend. Equals p-value for ad spend. Equals coefficient social reach. Oops, I actually picked the name instead. Coefficient social reach equals p-value for social reach equals coefficient active users equals p-value for active users equals coefficient customer rating equals p-value customer rating. Now, when we get to subscription price, you'll notice it's not in the model because we deleted that column. So we just put NA for subscription price. And so that can either be capital N/A, it can also be little n/A. It'll take it either way. All right, and then finally we have the standard error. And the standard error is this one up here. It's the standard error for the whole model, as opposed to the standard errors down here, which are for individual coefficients. All right, now our predicted revenue down here in the prediction table, and this is now with new data. This data was not in the table, so this is new data. And we're saying, hey, if we had these new data points, what would we predict based on this model? And the way that that's done is we have to complete our regression equation, which is going to be the intercept, and that has to be locked because we actually are going to copy this formula. Plus what? Plus ad spend, and that's locked, times the ad spend here, which is not locked because when we copy it, we want that one to keep shifting down. Plus social reach locked times social reach not locked plus active users locked times active users not locked plus customer rating locked times customer rating not locked. All right, now what about subscription price? We can't include that in the model. It's not part of the equation, and in fact, if we had NA times something, that would throw an error, so we just leave it off the model. In other words, literally, the subscription price will have no effect on the final model, or let's put it this way, no significant effect, no statistically significant effect. All right, and then that would be our prediction based on this data. We know all predictions are flawed because of sampling error. So how flawed are we? Well, what we're going to do is calculate how flawed we are. So we'll say that equals this value minus 2 times the standard error, which is locked. And then over here, we're going to say it equals the predicted value plus 2 times the standard error, which is locked. And then we can copy this formula, these 3 formulas down. When you copy them down, interestingly, this last row, which we're going to use as an experimental row, meaning you can type in any values you want, and one of the questions will actually ask you to fill in values. But because we have no values filled in other words, these are treated like zeros, and so if you go through the regression equation and make all the coefficients 0, well, then in the equation term, all these become zeros, which leaves you with the intercept. That's why this value initially is 83.28, because that is the intercept. Okay, so now let's answer the questions. What does the standard error of 50.31, this number here, represent? And what it represents is C. On average, predicted monthly revenues differ from actual revenues by about 50.31K. Remember, because all this is in thousands. Interpret the coefficient for ad spend, 1.83. Remember, that's also in thousands. So this is then going to end up being D for each additional 1,000 spent on advertising. Predicted monthly revenue increases by 1.83 thousand, holding all variables constant. Which variables were included in the final model for predicting monthly revenue? Right, well, it was everything except subscription price. So it can't be A, it can't be C, so it's going to end up being B. Interpret the coefficient for social reach, which is the 0.1. So not a very big coefficient, but still statistically significant. And this is for every 100 additional followers, predicted monthly revenue increases by 1K, all the variables held constant. All right, now that's the answer, but that seems a little surprising, right? How does that work out? Well, remember, this is 0.01 times, scaled up to 1,000, which is how we get that to 100 followers. So it's kind of weird, right? So 100 times 0.01 would get that to 1. When that's a 1, it would raise the Y variable, which remember never appears here, but that's monthly revenue. It would raise the monthly revenue by $1,000. Okay, interpret the coefficient for customer rating, 71.85. And this is going to be C. Each 1 point increase in average customer rating increases predicted revenue by $71.85K, right? So that's a lot, holding all other variables constant. What's the interpretation of the intercept 83.28? It's the predicted monthly revenue when all predictors are 0. Remember, we saw that down here. Not meaningful in this context. And using the experiment row, so now we're going to go ahead and fill this in. Ad spend 90. Social reach 30,000. Active users 4,000. Customer rating 4.9. And notice we don't have to have a value for subscription price. I mean, we could have one. It would just be ignored because even if we put a value there, it wouldn't be carried forward to the equation. And so our prediction based on that data would be 1,101.67, which is B. And what's fun about this is you can put any numbers you want and actually watch what the prediction would be. All right, interpret the coefficient for active users, 0.08. And so this one is going to be each new active user adds 0.08K or $80 to predicted monthly revenue, holding all other items constant. In fact, if you think about it, remember this question, which is kind of hard to understand, could have also been done in terms of, instead of 100 additional each one, but then it wouldn't have been 1K, right? It would have had to been scaled accordingly. And we're good to go on this one.